Hello, and welcome to the Boeing Gearbox Inspection Team Showcase. I am Andrew O'Donnell, the project manager of this report, and I will be guiding you through the showcase today. So Boeing gave us our project objective, which was basically to build a design that improves upon the kind of quality assurance tools that are used in the industry today to inspect the inner workings and pipings of gearboxes for any defects or chips that could be harmful if they were put into use in aircraft engines. Due to limitations this year with COVID, all of our meetings and documents were exchanged virtually online through Zoom, through WebEx, or through Microsoft Teams, and this allowed the team to work off from our remote locations at the same time. Before moving into concept generation, the team had to see what was out there on the market and have something as a reference. So we bought a DevSpec borescope. This borescope had no guide system, a Wi-Fi connection, 2-megapixel camera, and this would serve as our basis for comparing our prototypes later in terms of performance. And then this pipe system here is one that is meant to simulate the kind of inner workings that you would see in a Boeing gearbox. And we placed it through here to see what kind of problems erupted when putting it through all these turns and bends and all of these angles. The entire device then was broken down into 3 subsystems for which we generated concepts. The first one being visual inspection method, second one being the actual user interface, and the third one being the guidance system through the piping system. From there, the team was then split into 3 separate groups that worked on the prototypes that arose from concept selection. We weighed the concepts against each other and against our customer needs, and the best ones that arose we took and we turned into, in terms of the cross model and the caster model here, returned into physical prototypes and then tested, and the track model was maintained as a CAD model prototype. In terms of performance, the caster design had very good centering, alignment, maneuverability, adaptability, and about the same ease of use. So this one generally was an improvement upon the typical reference borescope, and it's a type of attachment that can be easily put onto the borescope systems, and it would help it maneuver better within these passages. In terms of the cross design, this design had better centering, alignment. It had about the same maneuverability and adaptability, and about a little better ease of use, but it was so simple that it may have trouble when it comes to making these turns and things like that. It depends on the size and the type of material that was used. In this case, it was just PLA plastic that was used, but we think that if another material such as a more sliding plastic, one that doesn't harm the surface, was used, it could also help with the maneuverability. And then our deliverables to Boeing in the end was just a generalized case study, one that showed kind of physical models, one that showed how it would perform, and we gave this data to Boeing so that they can further make some high fidelity prototypes and ones that might be better suited to their needs. And that is how we went through the project for the entire year. So thank you so much for watching, and we hope you enjoy it.